I'm Ricky Nathvani, and earlier this week I caught up with Dr. Giovanni Traverso from the Brigham and Women's Hospital at Harvard Medical School, who collaborated with the Electrical Engineering Department at MIT to develop this stomach acid-powered battery.
When you start thinking about sort of longer timescales, the standard battery becomes insufficient. And one of the approaches that we've explored, which is exactly the one that's reported in our paper in Nature Biomedical Engineering, is harvesting energy in the stomach, then specifically using the gastric acid and the reaction that can occur with different metals, akin to a potato or a lemon battery that many folks have probably been exposed to in school.
Here's a quick reminder on how that classic school experiment works. Take an ordinary lemon, ripe full of citric acid, and stick in two different types of metals, typically zinc and copper, and connect them through a circuit. The metals in contact with the acid are called electrodes. As the zinc dissolves in the acidic environment, it leaves behind electrons in the metal that are free to run round through the rest of our system to the copper, where the hydrogen atoms in the acid recombine with these electrons on the surface of the copper and complete an electrical circuit, generating power. This stomach acid-powered battery works the same way. Instead of a zesty citric acid in a lemon, your stomach provides hydrochloric acid, and the zinc and copper generate a small current.
The electrochemical reactions that are occurring between the acid environment and the metals that help generate that transfer of electrons and that current, we're able to store that energy and then use it every so often to do the kinds of activities that we're interested in doing, like sensing. And in this case, in the first proof of concept, we sensed temperature and then communicated that out to an external receiver that was situated a couple of meters away from the pigs that we worked with.
And these pigs, were they okay after this process?
I mean, these animals, went about their daily routine as they would otherwise, eating and walking. They did absolutely fine. We didn't see any changes in their weight or their feeding patterns. And I think it really sort of highlights the fact that this is a capsule that's sort of slowly transiting through the body, but really, other than harvesting, which it's doing in a way passively as it's transiting, it really isn't causing any other side effects that we're aware of.
Because the electrode zinc that's being used for this energy harvesting, actually zinc is deposited in the body all the time anyway, right?
Right, and so we selected the electrodes carefully to ensure and maximize the safety. I mean, I think one of the things that we're looking to do in the future is really to understand and ensure that chronic usage of systems like these are indeed safe in mammals, but at least in this initial study, we did not see any adverse effects from these systems.
And how big do these devices tend to be? Are we talking about the size of a pill?
They're the size of a large fish oil capsule. The dimensions are approximately 1 centimeter in diameter and about 3 centimeters in length. So these are good size for systems that have to be swallowed.
As Giovanni explained to me, the hope is to use this mechanism to power high-tech medical capsules called ingestible electronics that can diagnose and treat us from the inside.
I think it really starts to open up possibilities with respect to gastric resident electronics. And
so these are electronics that stay in the stomach, right?
Correct, for prolonged periods of time to measure different parameters. And so for us, at least, it introduces the possibility of using ingestible electronics for very precise, finely tuned drug delivery from systems that perhaps one day we can have reside in the stomach over the course of many days or potentially many weeks.